Okay, live for real this time. So welcome back. Today I'm going to be continuing to work on my virtual machine. So last time I was trying to get strings to be stored on the string stack. And I did get that mostly working. So if we look at this, I made another union, right? This one's called data. So that can either be a word or a string. So you can interpret it, yeah, either one of those ways. And then here is the string stack, which should probably be renamed to the data stack. Right now I'm just going to implement strings for it. In the future, though, it could be used for storing any kind of data, and sort of as like a global variable, because there's no way to actually remove from the string stack or the data stack. So I think that's a good way to utilize it. But for now, it's called the string stack, because that's what I'm using it for at the moment. So if we look in here, I have, let's see, it's all the way down here. So when we write to the file, we open it, and then, yeah, for each thing in the string stack, we write it to the file, just like this. This is the string length plus 1, so that we get the null termination character. And yeah, and we interpret it as a string. Then at the end of that, we write data ends, so we know where it ends. Now this should probably be something a bit more obfuscated. So like if you just make something called data end, then it's going to be detected as the data end. But yeah, for now this is good. Yeah, and then we just write the instructions. And then when we read it, so at the beginning of the file is the data. When we read it, yeah, we go through this. While it's less than the max stack size, we go through that. That's the character index, alright, and we read each character, and we create a string until we get to the null termination character. And then we check to see if it is equal to data end, and if it is, then we break out of this. So this is just adding stuff for information. So then we can go here. Yeah, I don't think we need this one actually. I'm coming out just in case, but this way we set it to the index, which is basically where immediately after the data end is where we'll jump to, so that we don't read that into the instructions. Yeah, and then here, machine, and then, yeah, so this is just reading the strings to make sure it works. So I can actually show that if I build this now. And then I have just a test file here, test.tasm. Let's see, test.tasm, there we go. So yeah, we're pushing 3 different strings, hello world 0, 1, and 2, with a new line at the end, push 5, and then print. So if we look at that, we run tasm, test.tasm, and then test.tin. Yeah, you can see we do actually have the extra new line, so if I get rid of the new line, let's make it clear. There we go. Yeah, so here's all the strings, and if we actually do less than or equal to, we can see that on the string stack there is actually data end stored there, which that's okay, because we don't actually, like, that way we know the data end, so it's always going to be there. So yeah, we don't need to print that out though, and you can see everything else still works. We pushed 5, that works, and let me actually make sure Fibonacci still works and stuff like that. And there we go, so that looks good. The writing stuff and the other stuff that was strings won't work anymore because we completely changed how strings work. So now we can push the string, but then we need a way to get it. So basically, it'll be something like get. This should really be called push data because that's what we're going to use it for, but for now I'll just do get string and then just the index. So 0, and that would push the pointer to the beginning of the string onto the regular stack, and then we can use that for whatever we want. So get stir. So we will need a new instruction for that. Perhaps there's a better way to name it. I'll have to think about that. Let's see. So we push stir. It's not really dupe or swap or anything like that. So yeah, I think it's probably going to be get stir. We'll just that'll be the name for now. Subject to change though. So let's see. Let's actually handle that in here. So this is going to be an actual instruction. Yeah. Whereas this, we can just assert false and unreachable. So we don't even really need to handle it in here. This could just be the default. But that's fine. Then here, inst getStr, and this we actually want to use. So actually, I suppose I will do this and then just not implemented. Implemented, if I can spell. And now if I build this, all right, no errors. So we need to handle this in the Lexer. So we'll add a type of getStr. And then as well, getStr.c, we can handle that. Let's see. And also for this, I'm thinking rather than using it like this, we could just have an array, which has all of these and the basically all the values that we have in here. So that's probably a good idea. And then we could use the same thing for this. But we just use this as the index, because they do correspond to numbers. So I think that's probably gonna be. Well, actually, I guess we couldn't really use it for this. We could though if. Yeah. So we could use it for both of these, and it would make it a lot more concise. So let's actually maybe define that in here. So we can do something like we can type, or let's see. So this is just going to be a text of type essentially, and then type count is the length plus 1. Yeah. Then this would just equal an array of each of these strings here. So what's a good way to just grab the strings? Let me just I think maybe better just grab this, and then we can just get rid of type. So if we grab that, paste it in there, and then I can make it all lowercase. Whoops, that's not what I meant to do. No, undo that. And this. All right, let's see if I can do it right this time. So I want this to be like that. There we go. And then we can get rid of type for all of these. So let me just query replace this. Type with nothing. Just like that. And then there we go. So now then we just need strings around all of them. Actually, let me get rid of these equals. So yeah, let's see. Can I put strings around all of them? Use that. So replace anything with right, that's not, no, I want something like that. How do I do it? I just replace the space. Let's see, the space and then the AZ. No, let's see, just the space with that. Right, something like that is pretty close. And this I can replace the comma with the same thing. Yeah, so if I just do a little something like that, and then replace the comma with that comma, enter. There we go. And let's get rid of this extra one here. And this here, and then let's just remove the new line from all of them. So if I do that, there we go. Okay, and then let's just indent that so it is. All right, actually, I want that on a new line. So see if I can. Nope, didn't mean to do that. And let's see. Yeah, there we go. Let me put this one on a new line actually, like this. That, and then yeah, so this should all be valid. And then here we can just go to there, new line, and then I'll just indent all this a couple times. No, I won't indent it. I'll just leave it like that. All right, so that should work hopefully, assuming everything is done right. Missing terminating character. So let's see, that's on sub. Ooh, okay. Actually, that's not. I didn't put a semicolon. Okay, count. Yeah, this is actually type count. Type count. And then, all right, yeah, type get sir is not handling switch. Oh, that's okay because we're not going to actually have a switch there anymore. This can just be basically just return type text. I think is that what I called? Text of type. All right, text of type token dot type, something like that, and then I'll comment this all out and then see if we get any errors. So then we should have, yeah, and then anything else, yeah, we can just return none. So actually, if basically we'll just check if token.type is greater than type count, then we'll just return none. Otherwise, we can return that. So that should work now. Okay, we do have some errors. Multiple definition of text of type. Okay. Type. Okay. So why is that? First declared here. First defined here. Let's see, where is that? Alright, can we change the name to something else? Token type text. Something like that. Token type text. Token type text. Alright, let's see. Nope, it still does that. So it's something. Did I define it twice? What did I do for this? Alright, I'm not sure why. Why it says define twice. So text. Yeah, so what's that about? Let's see, token type. I'm gonna move this all onto one line again. And see that. Let's see. Okay, so what's the issue with that? I don't. Alright, what if I define it just in here, like right there? Alright, stuff is lagging now. So it doesn't like that. Well, I didn't actually save this, so that's going to cause a problem. Okay, and then it works. So, but if I delete this and then move it back in here, it doesn't work. So I guess it doesn't like me declaring stuff like that. Yeah, okay. So, yeah, that's fine. I can just put it in. Well, actually, we want to use this outside the script. So, outside, not the script, this file. Can I put it? Yeah, maybe I don't need to use outside this file. Alright, well, so that's probably good. And then we can do the same thing down here, essentially. So basically, if name is the same as shoot, actually, because we don't have that, do we? The token, the index of the token. So yeah, so that might not work. Well, we can use a for loop for this. Less than count. If name is the same as type, what's it called again? Token type text of I, then return return, basically we can just cast it. So type as token type I essentially, and I think that'll work. And then otherwise we'll just return type none. Do I have a type none actually? Or yeah, I do. So yeah, that's good. So previous definition again. Go ahead and save that. Alright, there we go. So let's see. Alright, so that didn't work. Let us see here. So let's print. Let's print the token stack and see what we get from that. So print. Oh yeah, because we aren't actually handling all the things properly. So in the parser, okay, let me make sure. So that did. We got get stir, which is what we wanted. Push stir. We have text. Yeah. All right. So that looks good actually to me. I believe, if I am not mistaken. And then in here, we do need to handle the get stir. So here we have the push stir. Basically we need to do get stir, and that will just have an index. So yeah, we could actually use the same one that we have here. Or lexer token slash index type equals type get stir. Because we expect the same thing, so that should be fine. Yeah, okay, so that should be fine. So now let's go into chasm.c, and we can add inst get stir like that. And let's see, now it should compile properly. Okay. We do need to handle this here. Or head value dot type equals get stir. Type get stir. Okay, something like that. So now let's run test.chasm. Okay, and then that seemed to work. So then test.in. False and not in. Alright, so that looks good. In Elixir, let's actually not print the Java name. Yeah, so it seems to be working. So I think I can just get rid of this now. All the commented out code that we have here. Yeah. I guess I didn't really comment this out, but that's okay. So now, yeah, let's get rid of that. And get rid of this. And now it is much more concise and readable. Yeah, so let me make sure that wasn't a problem. Select him, and there we go. Alright, yeah, so everything seems to be working now. And that's a lot better. So in here, now we need to actually handle it. So basically, we'll just push onto the stack the pointer to, let's see, where it's actually up here. So basically we'll push pointer past the machine, and the machine, let's see, serve stack size. We actually need a string stack pointer. No, we just need a, so we'll do a equals pop. So this will be the index. No, actually we just want the machine instructions ip.value as in. Essentially is what we need there. So that I think should work. And then the pointer should be on the top of the stack. So that is a data. Yeah, so dot stir, and we can actually cast this to a word here. And then, alright, so that might not work actually. So let's do something like word stir equals equals machine instructions ip value dot as int. Basically what we're doing there. So actually we need the machine string stack, and this is the index stir, and then we can just pass that in here. How goes it? It goes good. How goes it with you? Alright, then that should work, I think. Unused variable stir. Oh yeah, so we need actually something like this in here so that there is a scope. Unused variable. Alright, oh yeah, I forgot a semicolon. Goes well over this way too. Good to hear that. Glad to hear that. Alright, push pointer. So who wants, oh yeah, okay, so this can be stir dot as pointer. Blah, blah, blah. Invalid initialize. Yeah. So why? So I seem to have messed something up with this. Da, da. Okay, but character pointer. So can we cast this to a void pointer? And then let's see. All right. And then if we run it, and let's actually false and not implement it. Did I not recompile it actually? Well, no. Okay, so oh yeah, because I still have that in there. Oh, I forgot to remove the assert. That is quite important. False and so we have push stir. Okay, so why is it getting to that point? Because we shouldn't be actually using that. It should be handled in the TASM.c. We shouldn't create type push stir. Yeah, here is that. So, oh yeah, so we don't actually want to push that instruction. So basically, if let's see, it's instruction dot instruction type equals type push stir, then actually we'll just do it. It's not equal. And then we can place this in here, and that should prevent that, because we don't ever want that in there. So let's try that again. Alright, so the instruction type is actually different. So it is inst push stir. Inst push stir, something like that. Alright, and then run that. False and unreachable. So it still is, oh yeah, because I didn't recompile it. It's not TASM. And there we go. Alright, so now we don't have that, because we don't need that. And we still get the strings regardless. So I can actually remove that this one here, because we don't need that. So what do we, so we push that, and we should have that. So let's try to print that out. In the test.tasm, instead of pushing 5 here, that should just print the pointer to this. So build that, and then run that. We compile it actually. And there we go. So we have a pointer there. So pretty sure it worked. If I just temporarily go to the print stack here and make this an S, like so. Yeah, it's gonna cause a lot of problems, but it won't work actually. So yeah, doesn't like that. So let's try to alright, let me go down to print. Because that was for printing stack actually. So this needs to be S right there. There we go. So now if I run that, it breaks. So it didn't work. Something did not work at least. So let's actually go here and let's print out what we push here. So that should be pushing the pointer. So let's actually print f gene stack and then stack size. Alright, I don't know why I did that. So this should be that. And then do cast it to a character pointer. And do this dot as pointer. Let's see. Something like that. Yeah, this needs to be machine stack size. Build that, and now let's try to run that. Alright. So it doesn't, let's see, doesn't even be -1. Alright, so it's not, oh, that's in the wrong one, actually. Yeah, because this is in quick pointer, not in get stirred. That's the one that I meant to be looking at. Segfault, and actually you did not run it. Alright, so it doesn't like that. What if we try to print just the character like this, and we interpret it as a character. Alright, so it doesn't work like that either. So what is, why would that be? So let's try to actually, in here, for in type 0 while I is less than machine, let's see, stir stack size is class, and let's just, print f, machine stir stack I. Something like that. And let's get rid of this one. And let's see. So format space type of character. Where, oh, that is down. No, that's up here. So, oh yeah, dot stir. There we go. Alright, so let's see now. So we do have access to those. Let's see. These should be the same pointers. Yeah, so it's not the same. It should be. Let's see. So this is, let me print, let's do A equals chain instruction IP dot value dot as int, and then just print A. And yeah, so I'm just temporarily using this because not the use of A exactly, but you can see what it says. Type word. So I love not knowing what's going on. Yeah, it's confusing watching someone else code to know what's going on ever. Yeah. So to int64. Oh yeah. So this is, yeah, this needs to be dot as in, and then this can be like that. There we go. Yeah, and this also, so we'll just do this, int64t, and I guess I won't call it A, I'll just call it, T for text. Whoops. I'm trying to understand how. Yes. Okay, wait. Shoot. Mess that up. T is set but not used. So, yeah, because we don't need the as int anymore. Okay, so let's see. Alright, so what are we printing actually again? I don't remember. T. So let's do value is, so I can see where it's at. Value is that. So this is the number. So that's actually an issue. It is not being interpreted like that. So, so what if I do like that, and then that work actually? Yeah. So make this B. Yeah. So it's not the right value. Am I using the wrong thing actually? So value, it must not be set properly in here, because it's supposed to be, let's see, it's supposed to be 0. Yeah, so after get stir, instruction value, so let's print f, not s, it's a b, toy head value dot text. And let's see what it said. 0. Okay, so what if we take this and do print the instruction value dot as int like that, format. Oh yeah, it's this. It is not just a regular ink. And it's still 0. So, but then here it thinks it's that. So, are we on the wrong index, perhaps? Get stir. So why is it called 3 times as well? Oh shoot. Actually, push stir. Are they getting mixed up, perhaps? That could be the issue. I might have messed something up really bad. Type push stir. And that should just be doing that. So then go through here. Push stir. Do I have these? Yeah, I do. Okay. So that was the issue. I had them mixed up in here. And it's based on the index. There we go. Yeah, so I think that'll fix it actually. Okay, and then let's run. There we go. Okay, so that is more like what I wanted to happen. So let's try to now print this. So let's get rid of that, and then we will just print machine stack size. Nice. Yeah, very nice. Let's see. Yeah, so that is I need to do as pointer. And then I'll just cast it to a character so there's no warning, even though it's a template. Well, char star, if you will. Well, that worked. Oh, yeah, I guess that didn't make sense to work. Aha moments, yes. Especially when it's something really stupid, where you just put something in the wrong order. That's the best. Okay, so value is no. So it did not print that still properly, but might need to do that. Value it, yeah, so it's still, it is closer. Alright, this, so that is what's at the top. Okay. So when we push it, yeah, so it still doesn't work. But so this is push the pointer of that. So I should be pushing the pointer on the at this index. And let's see. So the index is which was this string instructions ip dot value dot as. So that should be essentially a like that. Whoops. There we go. So this should be index is 0. So, and then let's actually see if, can I do machine there's that 0 dot start. Alright, and then run that. Yes, that doesn't work. But up here it does. So what is different? Because this can print it out as the string properly. Okay, so it starts at 1. Okay. Well, that's an issue. I'm not sure why that would be. We can do that temporarily, but I need to figure out why it is doing that. Yeah, so actually this. Yeah, so actually, 1. So we can print. So why does it start at 1? That's what I need. Let's see, 1, 2. So we have 4 on there. Print out is the string. Without the new line, because. Alright, and let's see now what happened. So I don't quite understand that. Okay, so it starts at 1. Why? That is weird, okay. So how did I do this? So index, this is where we're writing it. Start stack I. Oh, it's because we start I at 1 here. Does that break it if I don't do that? Yes, okay, it does actually break stuff. So I don't remember why. But that's why it starts at 1. So temporarily I could do this, and instead of I, just put stir index in here. As well as this one. Just so it works. Still doesn't work. Okay. Did I forget another one? So is there another? So this is actually where it breaks actually. Yeah. Alright, well, so it'll start at 1 for now. Yeah. So why is that? Or I know why, but I don't remember why I did that. So I'll need to look at that. But it does work if you start at 1. Except this still doesn't work. So yeah. Some stuff works, some stuff doesn't work. Okay. So index is 0. And then if we add 1, so let's do index equals this. Value dot adds int plus 1. And then we'll make this we'll print the index here. Whoops, I didn't make that. Alright, index. And then here we'll use the index. And it should all of those should work. And it is not that, so okay, index is 1. Alright, and then here it doesn't work. So okay, and then that does work. So it's because, yeah, when you pop it off, it actually subtracts 1 before it. Yeah, okay, so it is working now, actually. If we print this down here in the print, if I can find it, print right here. Yeah, if we make this a string again, it's gonna errors or whatever, but it does print it out properly. So now we can store strings on the stack, pointers to them, in the stack index. Hello, Bob Ross RTX. How are you doing? How are you doing? Yes. Alright, so that is cool. It's like an off by 1 kind of thing, but okay, I think I should use this as index, instead of this. So put index here, make sure it all works. Being intrigued with what you're doing. That is cool. I am intrigued with what I'm doing too. You know, I don't really know what I'm doing. But yeah, so that all works. So that is good. So now we store strings on the string stack or data stack, and then we can actually get the pointer to them. So if we change this in here to the 1, then we'll get this one instead of the first one. So if I build it, I didn't actually need to do that, but then let's start. Okay. And there we go. Actually, I'm not printing it out anymore, but trust me, bro. Okay. Yeah, let me make sure it works actually. What VM are you building? I'm building I can show you in a second kind of what it is. Just let me make sure this works first, and then I can do that. Hello. Yeah, alright, so it did work. Basically creating your own JVM runtime for like your own custom language. Well, so it is similar to the Java virtual machine. It is just a custom one instead of the Java one. And basically, I'm building the virtual machine as well as the assembly for testing the virtual machine. And then, yeah, I'm going to build my own custom language on top of the whole thing once it's mature enough for that. Obviously not JVM, but similar. Yes. Yes, it is similar to that. It's a stack-based virtual machine, similar to the JVM. And yeah, so that is what I'm doing. Yes, so alright, and let me actually move this print, since we know it works now. Nice indeed. Yeah. So now we need to redo write because write and stuff won't work anymore. The native write in here is pop the machine. So we want the string. We can just actually now pop the machine, and that will be the string. Yeah. Just pop it as pointer and cast it to a character pointer. A char star. That is gold. You got a GitHub link. Yes, I do. Right here. So there's the link like on the stream, but that's linked directly to the project. Yeah, and then stream.as pointer. Okay, so that's fine. Length is that. And alright, so I don't think I need to do this anymore. So I'll comment it out. And then write should work if you do it in the right order. So let me just make sure. So write. And we need to push 1, which is going to be standard out. And I think that's all that we need actually. So let's build that. If not TASM. Alright, undeclared. Oh yeah. So actually write is not a label. I need native one. Alright, and let's see. So build it now. If.tim. Hello world 1. Okay, and if we change this getStir to 2, then it should be hello world 2. And I didn't recompile it, so that's why it didn't work. And there we go. Alright, so that is pretty cool. Now the strings work a lot better, because before I had the strings, and they were working, but it was kind of a mess. Whoops. It's not in. And there we go. So I need to consider this. I'll play around with it when you next merge branches. Okay, very cool. I'm going to update the tests that I have, and then I'll push the changes. So, yeah. And let me just close all these, and then back here. So, let's see. I think that's not TASM. Yeah, so I can just kind of remove that, because I don't need it. And then let me just copy paste test slash hello world to here. Actually. There we go. And then I guess didn't need to copy paste it. So push string. And then this is getStir. GetStir 0 because that's the index. And then push standard out and write. So that should work if I actually move this to test. And then I run hello world. Test. Okay, so oh yeah, push to hello world, and it automatically gets the length. So that's cool. Bob Ross RTX just followed. Thank you. I appreciate that. Alright, so now we should print hello world. There we go. Alright, so the hello world example works. Let's see. So then I think read should be fine. Let me make sure. Yeah, because that doesn't use any of that. Exit, I think I did have, yeah. I have this, so this needs to be push stir. And then the reason it has to be, yeah, so okay. This is just to make sure it works properly, basically. And then, yeah, so we can push that. We can get stir 0. And then we push standard out, right? And we'll make sure that works. Exit.TASM. Exit.tim, and there we go. Alright, and then we can check the exit code. Yep, 69. Nice. It works. So now we have open.TASM. In this one, we use write. So for this, let's see. So we need to push stir, and then we need to get the stir. So I don't know that we need that anymore, but yeah, so this so then I think we need to do get stir 0 and then swap. Something like that I think will work. That's not test. No, it's not test. It is open up. Fire open.tim and then test. And let's see. So if you look at test, there's a lot of weird stuff in that thing. Okay. It did work though. I'm not sure what happened to the name though. Let me remove that. So then try that again. Let me recompile it. tim test. Alright, it still has that. So I'm not sure what that's about. Because it wasn't doing that before, but it was sometimes doing it. So yeah, I'll need to look into that. But it did work. So that is the important thing. So all the tests work for the most part. Let's see. So is there any other one? Let me just test label. There we go. And okay, so that is expected output. And then what else? Yeah, so I think that's all good. So it all seems to be working. I just need to check one thing and then I can push the changes of this. So in the Hasm.c, let me see. In here, I need to check when we push. Yeah, we don't want it to be, let's see, when we push, we don't want to add that, but I think it's fine because we aren't doing that. So actually, we need to separate this out into a different one. So I need a function for just expecting, so that you can expect the next one, but I'm not doing that right now. Instruction, maybe after the I push it, equals type push stir. Then we'll do this instead of checking in here, because otherwise you'll be able to just use regular push, and we don't want that because that is confusing behavior. And then yeah, I'll just do the same thing here. So one of these, get rid of that, and just make it an if statement. Actually, maybe I can just check if it does not equal that, then we'll have an error. And then error expected string. Well, actually, we shouldn't get there because we do check the errors in the parser. So maybe there should be an assert. False. And why are you here? There we go. And yeah, so we don't need that. Then that should work. And let's just get rid of this here, because now delete all that. And then right here, we can just get rid of this entirely as well. And then I'll make sure it works still. Alright, comparison. Let's see, type push stir. Oh yeah, so we want to actually check the head value dot type. Okay, and then I go into test, and then hello world.tasm, hello world.tim, and it works. Okay, so that is good. So I think I can push these changes now. So let me actually update the readme, and then I'll push it, because we have the example in here that doesn't work anymore. So push stir hello world, and then get stir 0. This is index of the string on the data stack. And then we push the standard out and right. Alright, so that all works. So yeah, okay, so that's good. Added data stack and ability to get the pointer to an index on the stack. So I need error handling and such in the actual virtual machine in case you put an out of bounds index or something like that. So I should probably work on that. This will go. And it should be up now. And I'm just working directly in main because, why not? I'm not collaborating with anyone, so I should probably do it the right way. And there we go. Now it is up. So hopefully it all works. There's probably still some problems. Alright, yeah, so that looks good to me. So now I have these examples here. I'm going to get rid of them. Or not examples, but stuff I was working on that I'm not anymore. So that was kind of, yeah. I'm gonna add some more tests with stuff like that. But now that we can work with strings, I think I could technically make like a FizzBuzz example or something like that requires strings. There we go. I should probably figure out what the problem with that was though. So if I go into here, whoops, wrong one, but not that. So let's see. So why is it, so this is where we are allocating for it. So let's do 6 rather than 4. Open.tasm, open.tim, test.txt, and then yeah, then it's just test.t, but it doesn't have all the stuff around it. So, and now if we run it, what if we do files like that? So that is the actual correct link. Files. Okay, so it did that. What if we make it? Let's see. So I think it's 8 would be the correct length. So let's try that. Recompile it. And then test.txt. So what is that? So then that has all this stuff. So I don't know what the deal with that is. So let's see if I can figure that out. That is in the, well, so it's either in the read, write, or open. It's probably in the open, because that's where we're actually creating the file. Let me actually see in here, open.tasm. Yeah. So we open it. Yeah, we open it based on that. So it's got to be an open. So let's just print the, let's see, we pop it off. Path. Where do we use the path.as pointer? Yeah, so what if we print f, cast it to character, path.as pointer, something like that. And then when we try to use it, so if I recompile it, as some open, I don't think I need to recompile it actually, path.txt. Yeah, so we do have all that extra stuff. So why? So there is something, it's actually could be in the read when we read it. Let's look at the read. Whoops. Okay. My mouse just went whack. Probably shouldn't be using a mouse anyway. So fread. I might be doing this wrong. So buffer. So that's what we're popping from the malloc. Length, we're popping as an int. So let's print f length. I could be using a debugger for this, I suppose, as well. Length. And let's see. Actually, I could do wait by save. And then we'll run this again. Whoops, it's open.tim. Length is 8. Okay, so that's fine. That's not it. Actually, does this go that way? Could that be the issue? Chasm or tire open.tim. That's not txt. No, so that, yeah, it's just new stuff every time. Alright, so we removed all those. So let's print the buffer after we read. So that is, yeah, buffer is that. Alright, build. Oh, whoops. There we go. It's like that. And let's see. Open.tim. Yes. Yes. Alright, so why did I have to do it twice that time? Okay. So maybe the buffer length is not right. So that's in here. Number of bytes is that. Let's actually do size of character times that. But that shouldn't make a difference. So let's print f. Num of bytes is num of bytes. So this is the first thing executed. And let's see. Look here. Num of bytes is 8. So that should be fine. Test.txt. And then yeah, it's all yeah. So right is that, so that's fine. Pointer buffer. What if we do something like that? Chasm. Alright, no. That's probably a better way to do that though, because it, yeah. So here, we can get rid of that. We don't need that. That's in the right. That's not where the error is. It's in read. It's probably in read. So we get the length. And the buffer. So this is, let's look at the cat open.f. So here, that's the size for malloc. This is the size, this length that we have here. This is the stream. So right here, we pop that. And then we just, yeah, basically this get stream just converts it to one of these, depending on what it is, and those are the ones that we handle at the moment. And actually that's in right. So where does it open at? Yeah, so it's the same thing. Yeah, and then length is here, and then the buffer is what malloc has. So if we call read, it pops this one off first, then the length, and then the output of malloc. So that should be fine. Yeah. And then we push 2 for open, which is the, yeah, which is one of these. So read write, or write read, whatever. Perhaps, could I, what if we change that to 1? That might not work actually. Yeah, let me exit out again. Open that pattern. Yeah. Delete it. There we go. So yeah, take that to 1. And let's see. Open that again. That's not txt. Yeah, it still didn't work. So yeah. Oops, I didn't mean a cat. I meant to. There we go. Okay, so let's see. That's not what the issue was then. I wasn't expecting that to be the issue really, but so when we print it out, it doesn't work. Mode. Yeah, so that's fine. The file descriptor is path.add pointer. So maybe, well, when we print it out here, yeah, so that is where it really gets messed up. So this is, let's see, this is, wants to work, there we go. Path in open. And then let's print it out as well in read. So after the length, after we read, then let's do path in read. And then this is actually a buffer here. Yeah, so like that. And then open that tagging. And there we go, test.txt. So path, yeah, so it gets messed up in both of them. So when we read, we must be doing something wrong in there. Let's look at fread. Yeah, so we have this, which is the malloc that we, and this is the stream, which is this one, which is, let's see. Yeah, so that is standard out. Is that right? Yeah. So then this is the size, and then yeah, so that's the length. That should be fine, right? So I'm pretty sure that is all right. So I'm not sure why it would be doing this. As right, let me go in here. Alright, so what if we do that? We don't allocate enough. And open that 10. Alright, yeah, so it still does that. Huh, I'm not sure why. So is it not, is it because we don't have the, not a single free? No. Yeah. I know. Because when I do it on stream, I don't even think about that. But I will go through off stream, like I've been thinking about that. I'll go through off stream and make sure I clean up all the memory and such. But yes, no free. Free. Well, there is free right here. So, actually, there is one. That counts, right? Okay. So, yeah, so what was I was thinking here? Perhaps, um, so is it not getting a new line character? Or a null termination character? That could be part of the issue. No, okay. Yeah, so that's not, so if we get, if we do buffer, length equals that. Yeah, so that won't work actually. Yeah, so I need to do, new buffer equals, and then do buffer length equals that. Alright, so that, let's just make this a character to start with. Because that should be fine still. Yeah, and then we do that. Instead of new buffer, we have like this. So push pointer, yeah, we need to do like that. Buffer. Alright, how can I do that? Go back to that. So it doesn't look like that. Make this a word instead of a character. And then not do that and do buffer dot as pointer. Yeah, actually, I want to do that. And it is a pointer, so actually, yeah, I don't want it to be a pointer. And there we go. Yeah, buffer dot as pointer. So when you got there. Alright, and then yeah, so I didn't actually add the null termination character. What if I just do that in here though? So what if I do like that? Yeah, so that didn't work either. Let's see. Equals yeah, let's make this actually like this, and we'll do length. And then this needs to be like that. And let's see, so use variable. Okay. Got that. And then let me do this, and we'll put new buff. Alright, yeah, so it doesn't like that. Alright, that doesn't work. Ta-ta. Index isn't cleared actually. It is one. Yeah, so I need to basically okay. Let's see. Okay. And then there we go. Alright, so that was the issue. There was no null termination character. So let me see if I can make this better. Buffer. Yeah, so that should be fine probably. Yeah. Hopefully that is better then. So let me try it again with a different name. Yeah, so if I do that, and then yeah, we get a bunch of new lines. So when it's not long enough, it does that. That's okay. Yeah, so that seems to work. Seems to work fine. Now let me actually do something else. So let me build all of these, all the tests. All right, and then build as well the windows executable for it. And then I'll test it using one. So I don't remember if it works or not. So make sure it compiles it. Okay. Well, that's a lot of stuff. I think it worked though. Let me remove open.tin and then make sure it works. Okay, yeah. So then wine and then not tin. Okay. S.txt, enter. Alright, and then alright, so that actually looks like it worked. So that is good. So assuming wine, what works on wine will work on Windows, then that seems to have worked. And then we'll try hello world.tin as well. And okay, so the bytecode cross compatible because that was compiled using the Linux one. Yeah, so that's pretty cool. Now let me see. I'll do a clean. Just get rid of all the extra stuff, and then I'll get rid of the debug stuff that I had in here. Okay, so that should be good now. Build it again. Okay, that's not txt is working. Okay, so I think also I do push through enter the file name like that, and then do push what else do I have to push? Standard out, and then write. Also get stir1, and then I do that. If I did everything right, enter the file name, and then test.txt, and there we go. So that's like a real actual program. So that is pretty cool. Yes. So now, let me remove the test.txt because don't want that there. Okay. There was something else that I was going to work on. Did you see the old IOCCC fourth entry? I did not. Do you have like a link? Or can I find it looking up that? Or how can I find that? Because I've not seen that. Mm. Oh, International Obfuscated C Code Contest? Da, da, da. Yes, do you have a link to that? I would like to see that. Okay. So now, what do I need to do? Link, here we go. Let me copy that. There we go. All right. Dun, dun. README. Let's look at that. I have to download it. Okay, give me a moment. Yeah, I want to just take a look at that. If I can open it. There we go. LeafPad, sure. Yeah, let me see. Check out Buzzard 2's design. Oh, okay. Got design. Let's see. Okay. So let's take a look. All right. What is language? Yep. Okay. So I've not used Forth, but I am familiar with it because of Porth. Yes. So, well, I haven't not familiar with the language, but what it is. Small because it can be coded in Forth. Only a small number of primitives. Okay. Small language. It's written in obfuscated C and rings in at under 800 bytes of source code. Although, it's brought to about 650. That's pretty cool. Yeah, this is not very good. The editor. First defines the first environment and primitives. Okay. Implements a virtual machine. Alright. Main memory, the stack, and string storage. Okay, so that's like what I've got. Just not the main memory part, but we have a stack and string storage. Unless that's like the heap. I'm not sure exactly. Virtual machine wishes to do random memory access. They come out of main memory. Cannot access the stack or string storage. Yeah, so mine accesses the stack. Stack is simply a standard LIFO data structure that is used implicitly. Okay. Made up of ints, whatever size they are on the host machine. Okay. String storage is used to store the names of built-in and defined primitives. Separate storage is used for these because it allows the C code to use C string operations. Okay. Yeah, that makes sense. Main memory is a large array of ints. When we speak of addresses, we actually mean indices into the memory. Okay, yeah, main memory is used for two things, the return stack and the dictionary. Dictionary is a list of words. Okay, so here's some operations. So minus, multiply, divide, fetch, and store. Okay. So yeah, this is like the fourth syntax, right? Echo, output top of the stack through put char, key. Okay, so all right, read a space delimited word. Though read could be synthesized from key, we need read to be able to compile words. Okay. Exit, leave the current function, pop the return stack into the program. Okay. Symbol name. Read in, all right, add it to the end of our string storage and generate a header. Pop the top of the stack using an index. All right. Yeah, see, so with mine, the stack is Like you can have arbitrary access. So it's not just a stack. So it's not really a stack. But yeah. All right, binary integer. All right, top of the stack is less than 0. Read from or write to memory. Okay, that's cool. Echo key output or input one character. Read. All right, yeah. So summary of all the first word. Yeah, so that's all the stuff that we looked at. Here is a sample first program. So find a word named L, output an ASCII L, and exit. And then find a word named hello, output H and E, push ASCII O onto the stack, push 2 L's, output the O, print a new line, stop running this routine. Hello, exit. Okay. Okay, so the word is like a label kind of thing. Okay, I see. That is cool. Cool stuff. First, there are a large number of important primitives. Okay, yeah, I'm gonna actually read through this. That is cool stuff. Whoops, I can't. There we go. This is reading for that thing. Yeah, so yeah, the link for that is in chat, and if I remember, I'll put it on the YouTube VOD when it goes up. It's this one right here. Yes, okay. Here's the, let's see, we can look at the actual C file, I think. .c. Yeah, okay. I don't want to download, so okay. Yeah. Cool stuff. All right. So where were we at? What do I have in the preview list? Nothing's in there. All right. So let me see. There was right. So there was something that I wanted to do with that. Well, actually, maybe could also have. I could. Trying to think. If we. So yeah, malloc. I'm just kind of saying nonsense, trying to think right now. Yeah. What are some more operations we could add, like these ones, the native things? Because we have open, write, read, close, malloc, free, and exit. So can we, let's look at Indium OS, something like this. We can look at the different syscalls. We have to use the C wrappers for them, essentially, the F-write ones, because so it can work on Windows. So is there some more useful ones that we can implement right now? Like, cause that would also be on Windows. Yeah. Maybe it would be better to look at the sockets. Ooh, okay. I should do one for sockets. I think the C sockets are cross-platform. All the stuff for that. Yeah, I've looked at this before. Yeah. Let me actually look at that. Right here. Yeah, socket. So does it say like like this is the, you do it the same way on both Windows and Linux, POSIX, whatever, right? If I am not mistaken. POSIX. Okay. I'm pretty sure it is. Right, this doesn't say anything about any of that, but so we could implement these ones. The basically these ones that you need here, and then we can use read and write obviously to communicate between them. Yeah. All right. Yeah. So maybe I won't do that now, but then we would be able to do actual networking stuff in the from the virtual machine. All right, and I think that would be quite cool, and it wouldn't be too difficult to implement. Stavros 33GR just followed. Thank you, I appreciate that. Do you have namespaces or modules? No, so there's not any of that in the let's see. Yeah, we only have basically just files, because it's basically assembly. This is in the actual language that I'm going to build. Like it'll be a higher level programming language. TV Josh just followed as well. Thank you. It'll be a higher level programming language, which will basically compile into the assembly, which compiles into the bytecode. So that will have more high level stuff. Maybe namespace. I'm not sure. But for this, it's kind of just basically is low level. Well, not super low level, because there is some certain things like, well, this is actually from the preprocessor that I built, the import, so you can include files and such. But it's more low level, and there's no safety checking, and there's not scopes or namespaces, anything like that. And I don't plan on having any of that in the assembly. Yes. But, yeah. So, and there's not really any documentation on it right now, other than the other than this one thing, basically, to show, sort of explain how it works. Other than that, I don't have anything because it's still constantly changing. And I think this is already updated to 29. Yeah, constantly changing. So once it is more stable, and I'm not really gonna add too many more features, then I'll write a whole thing of documentation and all the ins and outs of the language, and then I'll start working on the higher level language for it. Yes. So I should probably in here, should I define anything else? So here, yeah. Anything. Let's see. .h. In here we have data. Right now it's just used for the string stack. Yeah. And so the max stack size, that is only 1024 right now, so it is kind of limited. Yeah. These I don't really need them anymore. In here, let me clean this up a little bit. There we go, like that, and then here. There we go, and now it is a bit easier to read them. Yeah. Yeah, maybe I should do that. There we go, and then extra space. All right. Now that looks a bit nicer. What else? What else? Average space lover followed. Thank you. I appreciate that. A lot of follows today. Yeah. Okay. Very cool. Now that is good. I'm just looking through to see if there's anything in particular that stands out that I should clean up. Need to do a lot for the memory management. So I do know that. We're checking this. So this is for a keyword. Yeah, so that's, maybe I should make, basically, because I do check that in a few different places, I'll just make a function, basically, sort of, which it'll use isAlpha, but it's basically, I don't know what to call it exactly, maybe just isName, and that will return a name, isName, and it just takes, takes a character, like, just a character, so character, and then if isAlpha character, or character equals underscore, then return 1. Otherwise, we'll return 0. And then we can just check isName in here. Yeah, rather than checking this whole thing, so isName current index. It might be a C function for that already, but I'm not sure. And then that checks both these conditions. And then we have a few other places, like with the labels. I believe we do that. Is there anywhere else? Let's just look. Is alpha. Oh, we don't use that in here. I know I do use it in the preprocessor. Hello again, Bob Ross RTX. How are you doing? Has been a while since you've been here, you know? Yeah. Okay. Test C. Alright, so I guess I don't use it in here. But I will add it to the preprocessor. Because I had that in here, but I don't want to modify this one because the tip here I use it a few times. I guess I don't use it at all. Oh, it's just is alpha actually. There's no underscore. Yeah. This actually checks for dot as well. But this one, currently trying to deploy my website. Yeah, I know. Deploying websites kinda a pain sometimes. I know what you mean by that. This got kind of messed up. Alright, that looks kind of messy, but so yeah. So I was checking it wrong. So let me go through and check again. I thought I did use it somewhere else. Yeah, right here actually. So we can do is name current index. And that can just clean up all this stuff. Alright, and need that. Is there anywhere else? Is alpha. Alright, there. So now that's the only place I would check it. So that is good. Whoops, I spelled index wrong. Let's see, it was up here, right? Yeah. Index. There we go. Okay. And then undefined reference to is name. Okay. Yep, I did that. Is name. There we go. Alright, and let's make sure it all works actually. So let me go into here. And that is, it'll just, any of them can be tested. Because all of them have keywords, so it seems to work. So that's good. That is good. So let me look in here. Maybe I could add the expect. So then instead of checking all this and then going like that, and we can just expect, and then yeah, we can just pass the argument. All right, yeah. So let me make that. So int expect taken or expect type, I suppose. Maybe it should be expect token. I think I'll probably expect token, and it will take. Let's see. So what do we use here? So, so we need basically. I think we can use. Let's see. The stream, did it die? My internet may have went out. That happens sometimes. All right. I think it's fine. Hopefully. If it's not fine. Somebody please let me know. Yeah. So expect token. So we need. I forget how to do arguments like that. But I need to check that. So we will need. Let me just take the whole lesson. That might be easiest to do that. And then just the type that we need. So basically multiple args in C. Yeah, dying. Might be dead. Alright. Let's see. Okay. CC. Basically, I want multiple parameters, I suppose, rather than args. Parameters. Alright. How do you pass multiple parameters? So not in C++. I want. Alright. This should show it, hopefully. It's something like ... token type. Yeah. Once it loads, I'll see exactly how to do it. With variable argument list. We could just use a list. I think that basically is what it compiles to. Yeah. So yeah, struct. But I just want multiple arguments. I just forget what the syntax looks like. It's where you dot something. Let me just do c dot in parameters. Let's see. Neighborless echo, if I pronounce that right, followed. Thank you, I appreciate that. Actual and formal. Alright, yeah. So C function parameters. I just want to see the syntax. Okay. Whenever it loads. Does it have the dot? That's what, nope. Alright. It does not look like. So maybe I should just use an array, because I do know how to use that. Just is kind of a pain. C indefinite program parameters. Yeah, all right, there we go. See, that's what I was looking at. So with dot list. So this is right. Okay, list. You have to include standard arg, it looks like. All right, I can do that. Let's say .h standard arg, something like that. And then, so then what we want, yeah. So we do that. Then, yeah. All right. So va with list, and then va start list, and all right. So the count, I suppose you have here. Something like that. Count. So you have to pass how many, I guess, is how that works. And then for I equals 0, less than count, plus, and then yeah, we'll just print the args for now. Arg list. All right. VAN. And then I'll just return 0 for now. So I just want to test this and see if it works. So in here, we'll just call spec token vector, and then we'll pass 3 of them, and we'll put type 1, type label, type float, just random, and it should print them all out. I'm not sure what order they are in, but Elixir, oh yeah, so we can pass the pointer to Elixir like that. Okay, unused parameter, that's okay. So let me try that. Chasm, open that chasm. 37, 33. So type none is -1, I believe. I can look. Chasm Lexer.h. Yeah, so -1, and then 33 starts here, 33 down. Type int, 37 and 33. So type label, that's 35. Well, it's 34 really, so let's do type push. Then yeah, build it again. Sorry, chasm. Okay, so one, all right, so that is good. So there's actually only two. So that should work. And then we can just check. Let's see. We can check for each one. We'll just have int return equals 0. So then we'll return. Well, actually, it can't be called return. We'll call it result. Yeah, so result. And then we'll go through each one. And then we'll do if lexer open stack index type equals va arg list int then result equals 1. So yeah, so that should check using i3 window manager or something similar. It is called awesome window manager. I've never used i3, so I don't know if it's similar, but yeah, right here, awesome. So it uses like Lua for the configuration. It's pretty cool. Has some cool stuff. I haven't customized it much. It's pretty much just the default with a couple things. Yeah, this is pretty much what my setup looks like right here. Exactly like this. This is probably just a picture from my room. Except the keyboard's a lot dirtier than that. Yeah. So this is what I use. Awesome window manager. Yes. Okay. So yeah. So result equals 1. So then if it's any of these, yeah, if it's any of those, then it should return the proper thing. That didn't work. Index. Yes, we don't actually have the index, do we? So we do need to include index like that. So we'll pass index right here, index, and then actually I'll just put it in here. Do that. All right. Now let's see. Okay. So yeah, print it every time. Time we go through, and it returns 1 every time. So that is probably not good. Okay. Well, so let's see. If we do something like yeah, so expect token. Let's do if. Actually, why did it print it out? Oh yeah, because we print it here. We don't want to print it. Yeah, let me see now. Yeah, so it doesn't print anything. We'll do if expect token, and let's see, mess that up. And then equals to continue, and then print f int or float or char or label. And then yeah, so then we'll pass all those in here. Type int, type float, type char, type label, and we have 4 of those, so 4. Well, actually, so I starts at 0. So I should probably, yeah, no, actually that should be fine. Okay. So let's see now. All right, I don't know that that's right. Let me see. So one that I definitely have is going to be push. So let's go to push, and we'll do it here. So then we'll just print f push. So yeah, we're just expecting type push. And then one argument. Push. All right, so let's see. Test cat lib.cat. And all right, yeah, so it works. And let's see. So we have one push. Let's see. Did I miss enough? Oh, but I guess it's a loop, so it's not 2 push, 3 push, 4 push, 5 push. So 5, and was that what we got? Test/lib.cat. 1, 2, 3, 4, 5, 6. So there's 6. I might have counted wrong still. 5, all right, and then 6. Yeah, so I think that is right then. So that looks good to me. So if let's try taking everything in here, putting it in here, get rid of the printf, and then just get rid of this entirely, and make sure it still works, and then use it again. Then slash test slash viv.tim. Having to use Docker, and Docker, yeah, Docker is a pain. I haven't used it much, but definitely is from what I've used it. Yeah, so fire is viv.tim, and all right, so it still works. And then let's delete this extra one. Whoops, there we go. All right, and then expect token. Let's see. So we need to pass the Lexer index, and then 1, 2, 3, 4. So type int, type float, type char, type string. This will actually be an if. Then we'll do all the stuff in here, which is print syntax error. Yeah, so I guess that's really not a very good test, but assuming that works. Alright, and we have an error, so didn't work. Let's see. Found int. So there is an issue. I'm not sure why it didn't put the new line. So let me see. Syntax error. I guess I don't include a new line here. I should do that. Yeah, so let's see, why did that not work? Alright, that's not right. But found int. Wait, what? Expected type of int, but found int. Okay. So I think there is an issue with how we are comparing it. So perhaps this doesn't work at all. Yeah. Da-da-da. Okay. So let's just print both of these. %d. So Lexer token stack index dot type, and then also var with it. And let's see. Actually, they're gonna both be the same. Yeah, they'll be the same number. So let me print it outside like this. So, yeah. So here is all of the things. And then we can see the last one before the error. I guess it didn't error this time. Okay, do it wrong. Seem to have made a mistake. So I don't know what is happening here. Let me get rid of that now. Yeah, so in big chasm 2. Alright, I have no idea how to pronounce your name. Just followed. Let's see. So Fiobe. I completely messed that up, and I very much apologize. But yes, thank you. Alright, 1, 2. So this one. Yeah, so it doesn't it's not working. The expect is not working. So we can get rid of this one. I think it is, let's see, so the way it's being compared, types, let's okay. Let's do Lexer token stack index type, as well as type int, type float, type char, and type string. Oops. There we go. And we'll add another few of these. 3 and 4, like that. Build it. And we'll run test slash fit.cat. Alright, so 32, 32. So those are the same. But then it messes up. Okay. Yeah, so it broke it. Okay. So they are the same though. Like you can see here. Let's see, where am I? So this is the type. That's the type in. But then it does break somewhere else. Slash fib.in. Let's see. Yeah, can't jump out of bounds. So I don't think I changed anything. And slash fib.cat. So 29. So this brings up a different error. And I'm not sure why exactly. Okay. Am I passing the index properly? So I don't know why this would break it. Let me revert back. So if, yeah, basically just do this here, but then also add or Lexer back type equals type char type no, it's not right. Index dot type equals type float. Type string is actually wrong though, so I don't know why I have that. Still put it in, but yeah, we don't want that. That's actually a remnant from before. Oh yeah, I didn't actually oh, so if that, then if Lexer open stack index dot type like push that, make that one. All right, and yeah, this needs to be index dot type. Oops, dot type. There we go. Next slash food dot pattern. All right, and then it's still, yeah, because right here. All right, and now or names that equals type char float. So now it doesn't work. Actually, this is supposed to be not equal. So that, oh shoot, that was the issue, wasn't it? I didn't rebuild it yet. Or no, I just did. So let's see, is there a different? Let me look in here. So I have the old one. I could do git diff, or I could just look here. So it is in parser. Yeah. So the token stack, it's not equal in. Oh, so this is supposed to be and. Yeah, so that's why it doesn't work. because it was used incorrectly. Yeah, so this is not or, it's and. Okay. So that was the issue. And that's why it wasn't working, because yeah, okay, so I just stupid. Oh, forgot to fix this. Did a stupid. Hello there, lunatics IO ban. Don't know how to pronounce that last part. But hello there. How are you doing? Test slash feedback. And now it works. Alright. Okay, so that's what the issue was. Let me zoom out a little. Or I'll just actually... Hello, YouTube recommended me one of your videos. Liked it a lot, so I'm here. Well, welcome. I'm glad that YouTube recommended and that you liked it. Yeah, so now... So I was just using that completely incorrectly, but this can still be the expect token. So token stack index dot type. No, it's just Lexer. And then 1 and type approach. You know, it's not particularly useful when it's just 1, but it's at least a little better. Nope, okay, so I guess it still doesn't work. So, because I did not provide the index. There we go. No, so what is that? Spec token. Did I index count? I need the 0, right? Alright, there we go. So that seems to fix it. Let's get rid of this print here. So let's try it on, let's see, this one. So this is good. So expect token, Lexer, and then the index, and 2, and type native, and type get stir. Alright, so that's what we'll use in here. And we'll make this an if. I wish I could learn C/C++. Well, why can you not? Okay, so yeah, forgot one of those. There we go. So that should work then. Bid.chasm. That's slash bid.tim. Okay. Yeah, why can't you? That's what I was wondering. Alright, so that works now. And then if this actually, yeah, we can do if not, or if expect token Lexer index 1 type int equals 0. Yes, then it's false, so that's what we want. Or we could just do not, I suppose, because it only prints 1 and 0, so yeah, then that should work still. And test/bid.tim. Okay, so that is all working. And then we can use it up here as well. So here, yep, spec token Lexer. Sadly, no job offers for them in my area, so first I have to learn web dev, get a job, and then I can learn them. I suppose that makes sense. Are you sure there's none there, like in your area? Like, because, well, C++ at least is still pretty in demand, like for like application development, and things like that. Like C maybe is more rare, except in like embedded systems or whatever. But yeah, so 1, 2, 3, 4, 5. Type in do. Type in swap. AKA I need money ASAP. I get that. Type jump. Type 0 jump. Type in z jump. Yeah, so we'll do that. This will be an if as well. Then get rid of that. And that looks a lot better. And let's make sure it still works. Bid.chasm. Test/bid.tim. And there we go. Alright. So now we'll leave this one as is. And then up here we can do a similar thing to this. So if It says only 4. Well, this is and actually, so why is it and? So it has to equal all of those? Yeah, I don't think that's right. I don't know that this does anything though, because I don't remember why I did that. Well, I can do it. I'll just leave that then. And I'll look into that. Actually, I see offers in automotive industries here, but they're all looking for seniors. Yeah, the need experience to get a job, but need a job to get experience. Yeah, so this, we can also spec token, Lexer, next one, type label there. And same thing here, if get rid of that, build it, make sure. Yes, like third dot tagging. So what is this then, right here? Why is it appending within here? So let me look at that. Type label that. Yeah, so why do we append this outside of the it? Okay, no token there. So is this supposed to be in here? Like, I don't know why it's outside. Does that break everything? It does break everything. So what's the deal with that? Oh wait, no, that was the wrong one that I made. There we go. Yeah, so this. Yeah, okay. So I don't know what that's about. I need to figure out that as well. I don't know about that. Is there any other expect token? This can be expect token, Lexer, index 1, right? Fish stir. Yep, same thing here. If. Whoops, and there we go. S/cat. It's not slash chasm. Or no, it's big. Dot chasm. There we go. I got it finally. Big dot thing. Pets. And it works. Okay. So I'm gonna say that's pretty good. So there's probably some other place I could implement that as well. And I will look into that. But now I'll make this. Added expect token function. We check if the token is correct. Basically. Yeah, so I'll work on that off stream somewhere. So I just push that and hopefully it worked. Let's see. No. Okay, perfect. So, let's see. All right, I think that is probably going to be about it for today. So yeah, if anyone in chat says anything or whatever, then I can respond before I go. I will just kind of clean up. Let's see. I'm looking here as well. Yeah, so 33, but that's not 31. Okay. Yep. Yeah. So, want to see something. So maybe I will look. Give me a moment. Software and game. So I'm gonna look to see if there is anyone doing something cool that I could that could be rated. I've never done that before, so I don't know how it works. I need to figure that out. So raid channel. Yeah, let me press that button actually. Raid channel. So yeah, let me find a good one. And then I will do that. Because there is 13 viewers apparently right now. So yeah, maybe there is someone doing some C. I don't know how to see, but I don't think I have any sounds. You can't hear it when I start watching it, but I want to find someone doing something cool. Jonathan Blow is live right now. rating him wouldn't do much, but yeah, one of the smaller ones. Streaming from Ubuntu. Live coding. Yeah, no one that I watch is live right now, so maybe there is someone, Twitch Developer API, something relevant. Java. Send everyone to Java, that'd be funny. Web development. Yeah, a lot of stuff here. What if I just come across mine and raid myself? Can you do that? If anyone has any recommendations or anything, like if someone who's live right now, C++. PHP. Alright, that's the end. Who's a good one? Let's see. Brain rust. Alright, that's pretty kind of relevant. Let's see if it's any good. But there's no sound, so no one will hear it. But oh, okay, yeah, it's not in English. So that's maybe not good. German, I think. I still hear it. There we go. Yeah. An English one. So I don't know how to check that, but let's see. About Godot. Anyone want to watch Godot? Here's mine. Yeah, I don't know. It doesn't look like there's a lot of just C here, which is kind of most relevant. Priority queue. So, alright, that could be cool. That could be a cool thing. Let's see. Self-raid, yeah. Yeah, this is Rust. Hopefully everyone likes Rust. So I will just, let's see. Alright, so I'm going to raid now.